Alright, now let's take a look at the L3 unicast routing, how it works inside the fabric when endpoint is known on both the ingress and egress leaves. For our example here, the leaf 1 and 2 are connected to VMA over port channel port channel 8, or rather we can say it's basically the VPC port channel 8, and leaf 4 knows it's directly connected VMB over interface 1/46. Routing inside the fabric would be based on equal cost multipathing protocol, the ECMP protocol. When the packet starts from VMA towards VMB, the leaf 1 and 2 encapsulates the source of that tunnel as the VTEP address of the VPC, and destination of that tunnel would be the leaf 4 TAP address. The VXLAN ID or VNID would be the context or VRF VNID. In this example, the unicast routing on both the bridge domains are enabled, and the VMs are in different EPG or bridge domain. The first command on leaf 1 shows the source VMAC known locally with its IP and the MAC address and the port channel that it's coming from, and it's flagged as learning to be local. Now when the same command is run to check if to check how this leaf knows about the remote IP address, which is 10.2.0.1.11, which is the IP address of VMB, it shows that it knows this IP address over tunnel 6, and it's peeraged. It's known through a peer, and further checking the details about this interface tunnel 6, we can see the tunnel destination is 10.0.168.95, which is nothing but the TAP address for the leaf 104. And if you remember the TAP address or the VTEP address that we are talking about here, it's basically the IP address that is assigned to every leaf individually during the fabric initialization in our very first video that we talked about. So similarly, when we check this same command on leaf 4 for its the IP address of VMB, it knows over it's connecting locally on interface 1/46, and the IP of VMB, it's learning over tunnel 2. Now the interesting part here is from VPC to leaf 4 there is a different tunnel, and backwards there is a different tunnel. So for both the communication we have different tunnels going on depending upon which part of the endpoint, VMA or VMB, is initiating the traffic. Here again, analyzing the details about tunnel 2, we can see the tunnel destination is 10.0.168.97, which is nothing but the VTEP address of VPC and not leaf 1 and leaf 2, because on VPC the two leaves act as a single switch, so there has to be a unique VTEP address to be assigned to this new virtual switch, which would be 10.0.168.97. So there would be a different TAP address for leaf 1, a different for leaf 2, and third one for a VPC for both these two. Now let's consider the L3 forwarding when leaf does not know the destination. In such cases, the packet is routed to the spine proxy. If the spine knows the destination endpoint in its COOP database, it will forward the packet to the respective leaf, or else it will try to resolve the R with ARP-clean. In L3 routing, the unknown unicast setting under bridge domain does not matter because it's an IP to IP forwarding and not MAC to MAC. Okay, time to understand how L2 and L3 packet flow inside the fabric, how they are basically processed. I'm not going to discuss this half of the flowchart because this has already been discussed in one of my previous slides, one of my previous videos. We'll just understand how the L3 packet is processed at different stages depending upon the configuration of policies and different settings in a bridge domain inside ACI fabric. Now first of all, when the L3 packet hits the leaf, the very first thing that the leaf does, it learns the ARP. Basically, it learns the source IP, the VRF, and the source MAC of the bridge domain. Now leaf checks if the leaf knows the destination IP endpoint. If yes, it further checks if the destination is local to the leaf or over the tunnel to another leaf or to a remote leaf. Based on that, the packet would either be forwarded on the local port or sent to the remote leaf. Then the egress leaf learns the remote IP and de-encapsulates the packet. Now, what if the leaf does not know the endpoint where the destination IP endpoint is? There again comes a situation where it would need to check if the destination could be reached through spine within the leaf or maybe outside the fabric through a border leaf switch. This further depends upon the bridge domain's subnet configuration for the destination IP. If the packet goes to spine proxy, it will either forward the packet or drop it. If the leaf finds out that the endpoint IP is known as an L3 out, L3 out means basically an external L3 domain outside the ACI, the packet would then either be forwarded to the border leaf. Border leaf is the leaf which is basically a connecting leaf between the ACI fabric and the L3 domain, external L3 domain. So it will be sent either to border leaf or as per the routing table, or it will be dropped. So this is how basically the L2 and L3 packet flow is processed inside the fabric based on the policies configured, and further depending upon if the destination identity is known or unknown to the packet. Sorry, to the fabric. Okay, so wasn't it exciting? I think it is when we as a network engineer, we get to know how packet is being processed inside the fabric at different stages. We always get excited. Okay, let's now understand how broadcast ARP request is processed inside the fabric. So when a broadcast ARP packet hits a leaf, it further depends if the unicast routing on the bridge domain is enabled or not. If not, it will flood within the bridge domain, and the if the uh, destination machine receives that ARP request, it simply replies to that ARP request, and the ARP request is entertained. Further, if the unicast routing is enabled, it then again checks if the target IP address is under the same ACI pervasive gateway subnet or not. If yes, it simply sends the ARP reply. If not, it again checks there is a configuration setting under bridge domain called as ARP flooding that can either be enabled or disabled. If it's enabled, then again it will flood in the bridge domain, and then we'll get the ARP reply. If not, it will further check if Leaf knows the target IP in its EPM database, kind of you can say the routing table of the Leaf, the EPM database or not. If yes, it will reply to that ARP. If not, it will again spend to the spine proxy. So at the end of the day, whatever is not known to any part of the fabric, it's being sent to the spine proxy, and thereon it will either forward or reply to the ARP, or it will just drop the ARP request and ARP glean for destination IP. Now very quickly let's see how ARP works. When an ARP request comes to a bridge domain with the unicast routing disabled, hardware proxy or flooding does not make any difference for broadcast ARP. Broadcast ARP requests are always forwarded. Unicast ARP requests are sent to the destined leaf node connecting to the destination. Now, when the unicast routing is enabled in the bridge domain, ARP will be processed and replied by the directly connected leaf. When the ARP request comes in for the remote endpoint in the bridge domain with the unicast routing enabled, the request is processed based on hardware proxy or flooding. Furthermore, the ARP flooding setting enabled or disabled in the bridge domain also makes a difference. These are simply the notes of whatever flowcharts that we have gone through in the previous slides. Just go through them, and they're really easy.